In this video, we're going to graph a quadratic function in standard form by hand. Remember, standard form is that form y equals ax squared plus bx plus c. So in our example here, y equals x squared minus 4x minus 5. Our a value is 1. Our b value is the -4. And our c value is -5. All right. First thing we're going to do is we're going to use the a and the b value. We're going to use this formula, x equals opposite of b over 2a. I like to put the b over 2a in parentheses, so I do that part first. And then I take the opposite value. So we simply substitute the -4 in for b, and then we say 2 times a, and a is 1. So here's my first step, x equals opposite of -4 over 2 times 1. Then that becomes x equals opposite of, well, -4 divided by 2. -4 divided by 2 is -2. So then we get x equals opposite of -2. So my axis of symmetry, or some call it the line of symmetry, is going to be x equals 2. I've already graphed that on the graph here. The red line there is the line x equals 2. So now we know the vertex of the parabola is on the axis of symmetry, but we don't know exactly where it's located. So to find that, all we do is we take the line of symmetry value, x equals 2, and we're going to substitute the 2 in for x. And so this equation has two terms with x values, right? So the x squared and the -4x both get replaced with the 2. So you see we have y equals 2 squared minus 4 times 2, and then minus 5. With all the order of operations, we get y equals 4 minus 8 minus 5. And you simplify that, you get y equals -9. So when x is 2, y is -9. So that's the point 2 comma -9, and that is our vertex point. So we plot that point right there to the right, 9 down, and it's on our axis of symmetry each and every time. So now let's use the c value from the equation. That always tells us the y-intercept. So we know another point that's on the parabola is the y-intercept. So we're going to plot the point 0, -5. Again, c equals -5. So the point on the y-axis is the point 0, -5. So that's the green point we plotted here on the graph. All right, the next thing we do is we're going to find one or two additional points on the same side as the y-intercept. So in this case, the y-intercept was to the left of the axis of symmetry. So I want to find two more points that are also left of the axis of symmetry. So you look at this, we know the line of symmetry was x equals 2. So one value you could plug in for x, substituting for x, would be x equals 1. So here we substitute x equals 1, and we end up getting -8. So we plotted the purple point, 1, -8. Then I'm not going to do 0. We already have 0, -5. So the next value for x as I go left would be -1. So we substitute -1 into the function, and we solve for that, and we get 0. So then we plot the point here, the -1, 0 is plotted there. So now we have the vertex point, and we have three other points to the left of the axis of symmetry. So now we're going to use the symmetry to reflect those points over the axis of symmetry to get the other points that are on the parabola. We don't have to do the math again. We know that all parabolas are symmetrical, so the vertex is the only point that's by itself. Every other point on the parabola has a symmetrical buddy, if you will, right? So the purple -1, or 1, -8, I should say, it's 1 away from the axis of symmetry. It's 1 to the left. So all we do is we go 1 to the right of the axis of symmetry. Boom, we get the point 3, -8. Look at my y-intercept, the green point, 0, -5. Well, it's 2 away from the axis of symmetry, 2 to the left. So then we're going to go 2 to the right. Boom, there's the point 4, -5. Right? Then finally, our -1, 0 is 3 units to the left of the line of symmetry. So we're going to go 3 units to the right of the axis of symmetry to get 5, 0. So remember, your line of symmetry in this example is x equals 2. So all I have to do is I keep the same y coordinate. So the purple one was 1, -8. So all I do is go 2 plus the 1. I got the 3. It's 3, -8. When I went up to this one, x is 2. 2 plus 2 is 4. And it has the same height. So the y value is the same. It's -5. So 4, -5. On this last one, the x-axis line of symmetry again is 2. We're going to add 3 this time to get to the 5. 5, 0. Again, the same height as its symmetrical buddy, the -1, 0. And our last step is now we just simply connect all the points, drawing a smooth curve to create our parabola. So it's nice and pretty and extended it for the entire graph. Officially, these are little arrows at the end here because it's going to go up, 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 and away, and it's going to keep getting wider, wider, and wider as it goes on. And that's how you graph a parabola by hand.